Okay, good morning, everybody. So you have a quiz next week in your lab. So you go to your lab session and write it in the lab. The way it works is that it is timed out to be basically a 1-hour quiz, but you get 90 minutes to do it. And then you write your quiz, and then that's it, you're done. So there's no extra lab activity after the fact. The first quiz is, we're only in week 3, so there's not that much to ask you about. Right, basically, I'm checking, do you know the basics of the Java language? So whatever differences there are between C and Java, more or less, right? The use of arrays, which should for most of you be okay because you did arrays in C. The use of strings. Now, don't go and memorize the string library. There's no point in doing that. I'm not going to ask you anything super hard, right? So know how to get the length of a string, maybe convert to uppercase and lowercase. Whatever methods are on the slides, at most, that's what you'll be asked about. I'm not going to make you go and read the string library and tell me all about it, right? And then the simple use of objects, so like making a random number generator and calling a method on it, right? Again, nothing that you haven't seen already. So if it was in the lab, that's fair game, right? If it's in the lecture slides, that's fair game. If you haven't seen it before, that's not fair game, so I'm not going to ask you about it. This does not include the use of lists or sets, so you don't have to worry about lists or sets for the first quiz. Right? I will post a sample quiz later this afternoon. I just have to go home and get to my office computer because I don't have anything useful on this particular computer. And so we'll do that shortly after class. Any questions about the quiz? All right, so let's do today's lecture and call it quits for the week. Unless you have the lab tomorrow. Okay, today's topic is maps. So I don't know if they teach you about associative arrays or not in your data structures course, but a map is Java's version of an associative array. Right. So different languages call these things different things. Java calls them maps. C++ also calls them maps. Python calls them dictionaries. Older languages refer to them as associative arrays. They're all the same thing. So they all are, a map basically maps one value to another value. That's essentially what it is. If you were in computing, you would take Sys 235 after Sys 124, and that's where you would learn about this sort of stuff. For some reason, the engineering curriculum is reversed. You do data structures before you do, I guess it's your second significant programming course, which is a bit unusual. Anyway, so a Java map kind of looks like a list, except the index, instead of using an integer index, you can use anything else. So you can use any reference type for the index, right? So in a list, you map 0 to the first element, 1 to the second element, and so on and so on and so forth. In a map, you can map a string to the first element. You can map a different string to the second element, and so on and so on and so forth. So like lists and sets, you get your choice of several different types of maps. Right? You can use a hash map. So for you guys, that would be a hash table, more or less. Right? So the hash map is more or less implemented using a hash table in Java. So it's very fast. Right? And normally that's the map that you would choose if you had no other reason to pick a map. Tree map for you guys would be a balanced binary search tree. So if you did just a regular search tree, it's not quite that. If you did red-black trees, that's exactly what it is. So the standard Java implementation of a tree map is just a red-black tree. It's essentially a binary tree where you can, it's essentially a binary search tree for the purposes of this course. Right? Everything is sorted, right? Just like in a binary search tree. If you want a very fast map and you want to guarantee, you have a very fast map, you'd like to iterate over the elements of the map in some particular order, then you can use a linked hash map. So that's similar to a linked hash set. Very fast. It remembers what order you put things in. And when you iterate over the elements, you get them back out in the same order. Right. OK, so a map models a group of elements that are accessed by what are called a key. Right? So that's the common language that's used to describe these sort of things. So the key is unique. Right? So the set of keys is unique. Each key maps to a corresponding value. Right? So in a list, your keys would be your indexes. Your values would be the elements. So your keys have to be unique. Each key maps to at most one value. Right? Multiple keys can map to the same value. So the keys form a set, right? The values do not form a set, right? So the values can be some sort of collection. These are called key value pairs. So those are just called map entries. So essentially, a map looks like, sorry, I'm just going to jump ahead to here and come back. A map is basically a two-column table. Right? The first column are your keys. Those are unique. Right? Your second column are your values. Those are not necessarily unique. Right? So notice that if you're going to create a table where you've got the months as your keys, right? Each month has a certain number of days. Right? The months are, of course, unique. Right? The days are not. Right? So January has 31 days, but so does May and July, and so on and so on and so forth. Right? If you need a two-column table where the first column is unique, you can use a map. Right? So a list, this column here would just be the numbers, right? 0, 1, 2, 3, 4, 5. So you can think of a list as being a kind of map where the keys are the indexes. Okay, so there's lots of different examples of maps for engineering and scientific purposes. Right? Map is just is sort of a model of a mathematical function, one-dimensional mathematical function, right? So each unique x value, right, maps onto a y value. Right? So if you remember what your definition of a mathematical function was that they should have taught you in first-year calculus, that's the same thing as a map. Right? You can imagine a dictionary, so like an English language dictionary that lists all of the words in the dictionary. The words are unique. But each word can map to, each word maps to a definition. The definitions are not necessarily unique, right? Many words mean the same things in the English language. Right? We saw the days of the month in the previous example I just showed you. Right? You can map the provinces to their provincial capitals. Right? Now in Canada, none of the capital cities, all the capital cities happen to be unique, but that's not necessarily the case, right? It is possible to have a country where you have two provinces with the same, with the capital cities having the same name. I don't know if there's an actual country where that's the case, but it's technically possible, right? And so on and so on and so forth, right? You can come up with lots and lots of examples of maps. All right, so to make a map, you just pick one of your types, right? So pick a hash map, pick a tree map, or pick a linked hash map. Generally, you pick hash map because it's extremely fast. Right? Everything, all of your fundamental operations are in O1 time. Right? So they're very, very fast. Your fundamental operations are get. So you're going to get a value out of the map. Right? You're going to put a value into the map. Right? And you're going to ask the map, is there a mapping having this key? Right? So those are your fundamental operations. Right? So that's basically search. Right? Search the map, get something out of the map, put something into the map. Right? Those are all very fast, all O1. Right? If you remember your binary search tree stuff from your data structures course, right, you know that a binary search tree, all of its fundamental operations are in O log n. Right? So searching a tree, getting something out of a tree, or putting something into the tree, assuming the tree is balanced, is in O log n. Right? And then there's linked hash map, which is basically a hash map that remembers the iteration order. Okay, so to put something in, so when you make a map, you normally end up with you normally start with an empty map. So you want to put stuff into the map. The method's called put. Right? So it's not, so in a list it's add, right? Because when you add something to a list, it always adds at the end. So it doesn't need to know the index at which you're inserting or adding to. Put needs to know what is the value of the key and what is the value of the value. Right? So if I want to make a map where the province names map to the capital city names, right? You just make a map that maps a string to a string. So notice here your generic types, right? You have one type for the key. You're allowed to have a second and different type for the value, right? So these don't have to be the same. Right? So we're going to map strings to strings, and we're just going to put the provinces in with their capital cities, right? So Ontario has the capital city Toronto, and so on and so on and so forth, right? The territories are missing intentionally. I'm going to put them in later, right? And so that generates that map there, right? Are we using a tree map? Yeah, we're using a tree map. So we're using a tree map here. So the provinces, when you put the province names in, they go in alphabetic order, right? Or they're maintained in alphabetic order. If you want to get a value out of a map, then you use get. and you pass in the key, right? So it's exactly the same as using a list. When you use a list, you use an integer value for a key. When you're using a map, whatever the key value type is what you pass in for the key. Right? And so our map is, the keys are strings, so I should pass in a string for the key. Right? Case matters here, right? So the string has to match exactly. So if I want to get the capital city for Ontario, it's just you ask the map to get the capital city corresponding to the key Ontario. Right? And that returns a string back here. If the key is not in the map, you get back null. Right? So you have to be a little bit careful. If you don't know for sure that a key is in the map, then you have to test the return value to make sure it's not null. Right? Because if it is null and you try to use the return value for something, you'll get an exception in Java. Right. So to test does the map contain a key, you just use contains key. Right. So here I'm going to now test, right, are the territories in the map or not. Right. So if Nunavut's not in the map, so not, right, so the map does not contain the key Nunavut, we're going to put in Nunavut and its capital city, Iqaluit. Right? And we're going to do the same with the other remaining territories. Right? And so there's an example of contains key and put again. Okay, so maps are, so a lot of introductory courses, you have to count stuff. Right? And so, for example, you might have a list of strings, and you might want to know how many times does each string appear in the list of strings. Right? That's a pretty common type of problem that you encounter in these introductory programming courses. Right? If you don't have a map, it's kind of a pain in the butt to do. But if you have a map, it's pretty trivial to do. Right? So the idea is that you're just going to loop over your list. Right? Every time you extract one element from the list, you're going to look in the map to see if it's already there. Right? If it's already there, you're going to get the count from the map. So your map is going to map words to the number of times the word has appeared. Right, so you just extract the count from the map, you add 1 to it, and put it back in. So this is very similar to the rolling dice example, except now we're using a map. All right, so I've got a list of strings called T somewhere. I would like to know how many times does each word appear in the list of strings. So I'm going to make a map called count. I'm going to use a hash map. You could use whatever other map you wanted to. Right? I'm just going to loop over the list. Right? So for every string that's in the list, I'm going to ask the map, right, do you contain that string? Right? If the answer is yes, right, then I'm going to ask the map, okay, how many times has that string appeared? So I'm going to use get. Right? So remember, contains key tests if the string is a key in the map. Right? Get returns the value that the key maps to, so that our map is keeping track of the number of times each word appears. Right? So ask the map, how many times has it appeared? Right? If it contains the key, that means I've already seen that value once at least. So I want to add one more to it because I just saw another instance of the string. So I'm going to add 1 to n and put it back into the map. Right? So ask the map to put back in, using that key, a new value. Right? And away you go. If you're using a newer version of Java, there is a way to do this in one step. I forget the name of the method, but I forget, and I also forget which version it showed up in. But there is a way to do this with a single method call. Otherwise, so if it doesn't contain the key, that means I'm seeing the string for the first time. So I'd like to put the string into the map with a current count of 1. Right? You run that loop, it processes every list in the string, it produces the map of counts. Right? You can just type that into Eclipse and pass in some string and see how that works. Right? It does, in fact, produce the correct count. All right, so your keys are unique, and that means in Java they form a set. Right? And that's exactly how the map is implemented. Right? So it keeps a set of keys, and it keeps the mapping from the keys to the values. Right? So you can ask a map for all of its keys. Right? The method keySet returns the set of keys. Right? Now, this is interesting. So we haven't seen this yet in this course. Although, some of the slides have kind of alluded to the fact that if you're using an array list, a lot of the slides actually just have list. So this is another example of that. So here's if you ask the map for its key set, and you look at the documentation for map, it says that the return value is just plain old set. Right? You don't know what kind of set it returns back. Right? All you know is that you get a set. It might be a hash set. It might be a tree set. It might be a linked hash set. It could be some other kind of set that you don't know about. All that you know is that it comes back as a set. Right? So when you use this thing keys, you can use whatever method set defines. Right? If you're using something like a tree set, and you look at the documentation for tree set, you'll realize that there are methods that tree set provides that set does not. Right? So a tree set is a particular kind of set. Right? It can actually do more than just a plain old set can do. And so later on in this course, you'll see that all reference types in Java actually have more than one type. Right? And so I guess in a couple of weeks, I'll explain exactly what that means. Right? For now, though, when you get the key set, remember that you're just getting back a plain old set, and you don't actually know what kind of set it is. Right? Now you can do something with the set. So for example, I can loop over the set. So for each string in the set keys, right, I can ask, hey, how many times did that string appear? Right? Assuming I'm using the count from the previous lecture slide. Right? So I can get the number of times each word has appeared, and then I can print it out using using println or something like that. Right? Of course, you can do something else with the keys as well. Here I'm just printing them out and getting their value. Okay, so the values are not unique. Right? So if you go back to the month example, right, the values are 30, 31, or 29, right, the number of days in the month. So they're not unique. You can ask the map for its values. Right? This isn't always useful, but sometimes it is. Right? So when you ask for its values, you get back something called a collection. Right? You don't get back a list. It's not a set because the values aren't unique. Right? But you don't get back a list or an array, which you kind of might think that you would get back. Right? Instead, you get this thing called a collection big C. And so when you use this thing collection, the only thing you can do with this, well, let's go ahead and look at the documentation for it. Okay. So if you go and actually look at what a collection can do, right, you'll see that, well, there's this method called add, which looks a lot like the list version of add. Right? There's a method called addAll, which looks a lot like the list version of addAll. Right? There's contains, which again looks a lot like the list version of contains. And there's some other methods as well. Right? There's a remove, looks like the remove from list. There's a size, so you can ask the collection how many elements are in it. Right? And a few other things here as well. Right? And if you were to compare that to the list documentation, you'd realize that all of the methods that are there are also in list. So it turns out that lists right, are also kinds of collections. Right? So again, if you have a list, it has more than one type. One of its types happens to be this thing called collection. Right? And again, we'll talk more about how that works a little bit later in the course. Right? So for now, if you ever ask the map for its values, you always get back this thing called collection. Right? Notice there's no get in collection. So the only thing you can do with the collection is, again, iterate over the values in the collection. Right? So it's sort of like a set in that regard. And so I can iterate over the collection, right, getting all the values. I can sum all the values, and that tells me how many words in total are in the map. Right? Or sorry, how many words in total were counted by the map. Right? If you want to know what the average number of times each word appears, you just take the number of strings and divide by the size. Right? Is there a bug? There's a bug. Right? That's an int, so you have to make one of these a double to get the correct floating point value out. And so you can compute the average word occurrence, or the average number of times each word occurs in that string that you processed earlier, that way. That's not the only way to do it, right? So you could do it this way as well. So you could iterate over the keys. Each time as you iterate over the keys, you can ask the map to get the value corresponding to the key, and now you could sum here as well. Right? So this is just showing you that you can also iterate over the values in the map. Okay, so key set and values, they both return. They don't specify exactly what kind of set, and it doesn't, values doesn't specify what kind of collection it actually returns. Right? This thing called set and this thing called collection, these are both examples of what are called interfaces in Java. Did I tell you what? Yes. So this is our first introduction to an interface. Right? Okay, so an interface is not a class, so that's the first thing you have to remember, right? But an interface is a type in Java, right? So big S set is an interface, big C collection is an interface, but big S set is also a reference type in Java. So you can actually make a variable whose type is big S set, right? Similarly, big C collection is a reference type, so you can make a variable whose type is big C collection. So what exactly is an interface and how does it differ from a class? So an interface is simply a specification of a bunch of methods. So when I say API, that's short for Application Programming Interface. For our purposes, it's just a bunch of methods. Right? So an interface says, right, what methods exist in the interface, but it doesn't say how they're implemented. Right? So if I go back to collection, right, the collection interface says there must be this method called add that returns a Boolean, but nowhere in the interface is there a method that's actually implemented called add. Right? So the body of add doesn't show up in the interface. Right? Similarly, the body for clear, the implementation for clear doesn't show up in the interface. So an interface is literally just a set of methods. Right? The list interface, which we haven't really seen yet, but it's the interface that ArrayList provides. Right? List says, specifies what every kind of list must provide. Right? If you have a class that implements an interface, then that class must provide every method that the interface says it has. Right? And so ArrayList, it turns out it implements the list interface. So every method that's in list, ArrayList provides the actual implementation for that method. Right? So ArrayList provides the implementation of the methods that list says exists. Right? List simply says these methods exist. Turns out list is what's called a sub-interface of collection. And all that means is that every method that's in collection is also in list. Right? So you've got this hierarchy of interfaces and collections. Of interfaces and classes. Right? Above list, there's this thing called collection. Right? List has everything that's in collection. Right? Above ArrayList, there's this thing called list. Right? So that means ArrayList has everything that's in list. Right? Down at the bottom, we've got poor old ArrayList. ArrayList is the one that has to do all the work. So whoever implemented the ArrayList class, they're the ones that provided all of the methods that were in list and all of the methods that were in collection. Right? So interfaces are reference types, right? And that means you can make a variable of that type. So, whoops, new, yeah, that's right. Right? So when you make an array list, right, or every time we've made an array list in the course so far, you've written array list t equals new array list. Right? It turns out you can write list t equals new array list. Right? If you're making a map, before I told you about these interfaces, you would have written hash map something something, count equals new hash map. Right? But it turns out you can just write map, key type, value type, count equals new hash map. Right? And so the array list, right? You can substitute an array list where you need a list, right? And you can substitute a hash map where you just need a plain old map, right? Similarly, you can substitute a tree set where you need a plain old set, right? This all works, again, because types in Java have more than one type, right? The ArrayList class, one of its types is ArrayList, right? Another one of its types is this thing called list. Right? For the class HashMap, one of its types is HashMap, right? But another one of its types is this thing called map, right? And so HashMap is interchangeable for map. The opposite's not true, so that's the funny thing in Java, right? If I need a hash map, right, I can't just use a plain old map, right? So the interfaces are not substitutable for the classes, but the classes are substitutable for their interfaces. Right? Again, we're going to see this in much greater detail later in the course. Right? And you might wonder why this works, why it works this way. So why would you ever want to do this, right? If I have an array list, why don't I just use ArrayList? Right? And so one of the answers is, the simplest answer is that if you write your code like that, right, and you program up whatever solution to the problem that you're trying to solve is, right, and as you're working on your problem, you realize that whatever ArrayList does isn't quite what you need, or it's doing it in a way that you don't want it to, maybe it's too slow, right? But you still want a list of some kind, right? It's just that you've realized that this thing ArrayList isn't the right kind of list that you want. Right? If you write your code like that, then all you have to do to fix the problem is find a class or a type of list that actually does what you want it to do and change that one array list to the other type. So you might realize that, hey, I really need a linked list in this particular problem. Right? If I just change that now to linked list, so I change one line of code, right? Everything else that you've written will still work. Right? You don't have to change any of your other code. So you can change the exact type of object that you're using on the right-hand side once, right? All of your other code still works, and you don't have to modify the rest of your code, right? Later on, if I decided, hey, I really needed a sorted map, right? I don't have to change. If I just wrote hash map here, then everywhere else I wrote hash map, I'd have to replace that with tree map, right? If I wanted a sorted map. Here, I just have to replace the right-hand side with tree map. So I only need to replace it once, as opposed to possibly many times. Okay, so these things, lists, sets, and maps, these are all part of what Java calls its collection framework. Right? Compared to C, this is a huge, this was a big advance, right? So C doesn't provide you with any data structures. Java gives you all sorts of data structures. Right? You get your sets, you get your lists, you get your maps, and you get a bunch of other stuff as well. Right? So the collection framework is made up of a bunch of interfaces. Right? And so these interfaces, they define what methods the various types of collections must support, right? So the interfaces for set, the interface for set says all sets must do this, right? The interface for map says all maps must do this, and the interface for list says all lists must do this, right? Exactly how those classes do what they do is undetermined by the interfaces, right? The classes are the things that implement the interfaces. So the classes are the ones that decide how are they going to provide these operations. Right? So for example, a tree set says, well, okay, I'm going to provide these operations, and when I provide these operations, I'm going to make sure all of my elements are in sorted order. Right? A hash set says, okay, I'm going to provide these operations. I don't care about the order, but everything's going to be really, really fast. Right? And so this lets interfaces allow the programmer to specify how things should work without saying exactly how they work. Right? And this gives you the flexibility to provide many different types of classes that all have the same interface. Right? Your classes are more or less interchangeable because they're using the methods from the interface. Right? But they have the ability to do things in different ways, perhaps more efficiently, right? Or perhaps in some way that's optimal for the particular problem you're trying to solve. Right? But it gives you the flexibility to change the implementation. And finally, there's a bunch of algorithms as well. So there's a bunch of classes that just have nothing but static methods in them. And those classes operate on the various types of interfaces. Right? So the collections interface, which I showed you when I talked about lists, it doesn't work just on lists. It works on any kind of collection. And that includes sets. Right? So if you want to sort a set, if you want to do something with a collection. So notice there's a collection with no S, and there's a plural collections with an S. So the one with the S, that's the class that operates on the various kinds of collections. Right? So notice here, there's a method called addAll, and it takes in any collection. Right? It doesn't just take in a list or a set. Right? It takes in any kind of collection C. Right? And then it takes in 0 or more elements. Right? It'll add all those elements to the collection C. It doesn't matter if C is a set or a list or some other kind of collection. Right? That method will work. Similarly, binary search. Right? So you can binary search a list. It doesn't matter what kind of list. Right? It can be a linked list. It could be an array list. And it could be some other kind of list. Right? That one method works for all of the different lists types. Right? And so on and so on and so forth. So there's a bunch of these methods. Right? A lot of these methods are list specific, but not all of them are. So anywhere where it says collection, like that, right, you can pass in any kind of collection that you want. Right? Max will find the maximum element in a list or a set, right, or any other kind of collection. Okay, so the collection framework is organized in a hierarchy of stuff. Right? So this is a hierarchy of interfaces. So that picture there that I'm showing you, this is an example of what's called a UML class diagram. Right? So UML is short for Unified Modeling Language. It's a visual language, so it's a language consisting only of pictures that's used to describe mostly object-oriented software. So what this picture here is showing you is it's showing you the relationship between all of the different interfaces in the collection framework. Right? So we've got a box. So all your types, they show up as boxes. Right? We have an interface called collection. If it's an interface, then it says it's an interface up here inside of this double. It looks like the double angled brackets. There's a French word that actually describes what that symbol is, and I can't remember what it is. Right? So collection sits at the top of the hierarchy. Right? And underneath that, you see there's something called list, which is also an interface. Right? Notice that list is connected to collection with this line and this open arrow. Right? Everything here is significant. Right? So the use of all these symbols is significant. Right? That's an open arrow. It's not just a pointy arrow or a solid arrow. Right? All of these things mean, all of the different symbols have different meanings in this language. So list is what's called a sub-interface of collection. And all that means is that every method that's in collection is also in list. Right? List is able to add more methods if it wants to. Right? So list can add additional methods, but all the methods in collection must also be in list. Right? What this is telling you is that list is a kind of collection. Right? If you've got a method somewhere that needs a collection, you can give it a list and that method will work. Right? So lists are substitutable for collections. Right? The relationship is one way, so it follows the arrow. Right? And so that means if you have a method that needs a list, you can't just pass in a plain old collection. Right? You have to pass in a list or something or a sub-interface of list, or a class that implements the list interface. Right? Set is a sub-interface of collection. Right? So you follow the line and to the arrow. So set is a collection. Right? Every method that's in collection is also in set. Right? They probably told you about queues in your data structure. There's also a queue interface. Right? So all queues are collections. Right? Every method that's in collection is also in queue. Right? Queue can provide extra methods if it wants. Notice that there's a sorted set interface as well. Right? So a sorted set is a set, which means it's also a collection. Right? Every method that's in set is in sorted set. Sorted set adds a bunch of methods that are specific to sorting a set. Right? So for example, sorted set lets you get the first element in the set. Right? So in other words, it lets you get the quote-unquote smallest element in the set. Right? It lets you get the largest element in the set. It lets you get a range of elements in the set. Right? So if you sort, so for example, if your sorted set is a dictionary of English words, right? This thing lets you get out all the words that start with A, for example, or all the words that start with W, and so on and so on and so forth. Right? So it adds extra methods that a plain old set doesn't have. Right. Oh, so okay, so we got some slides here that explain what I just said. Right? So everything in that second level there, right, those are all sub-interfaces of collection. Right? They all provide the exact same methods that collection has and may provide more. Right? All of the ones in red are substitutable for collection. Right? If you need a collection, you can use any of the things in red. Right? Sorted set is a sub-interface of set. Now it's not, there's no relationship between sorted set and list. Right? And there's no relationship between sorted set and queue. Right? The relationship is strictly between sorted set and sorted set and collection. Right? Maps are different. Right? You might ask yourself, hey, wait, this is the collection framework. Where are the maps? Right? The maps are separate. They have their own interface. Right? So all maps are described by the map interface. Right? And there's a sorted map interface just like there's a sorted set interface. Right? So tree set provides the sorted map interface. Sorry, tree map provides the sorted map interface. Hash map provides, just provides the plain old map interface. Right. Oh, okay. So what does collection do? So a collection represents a group of objects where each object is called an element of the collection. Right? So it doesn't say every element has an index, right? It doesn't say anything like that, right? It just says it's just this group of elements, right? And so you ask yourself, well, if I got a group of elements, what can I do with a group of elements, right? Well, I can do the following, right? I can ask for how many elements are in the group, right? So that's size, right? That's exactly the same as the list size method, right? How many elements are in the list? I can ask, is the collection empty or not? Right? Are there more than 0 elements? I can search the collection. Right? Depending on the exact type of collection, you may or may not be able to add an element to the collection. Right? This method is optional. Right? You can remove an element from the collection, assuming it's already in the collection. Right? There's this method here called iterator, which we haven't seen yet. Whenever you write a for each loop, the for each loop internally is calling this method called iterator. So if you see a type, or if you're reading the documentation for a type and you see it has an iterator method, immediately you know you can write a for each loop over that type. Right? So all collections provide iterator, and that means I can use a for each loop on any collection. Right? That's why I can write a for each loop with a list. It's why I can write a for each loop with a set. Right? And then there's a bunch of other methods as well. Right? We don't need to know what all these methods are right now. Remember, list is a sub-interface of collection, so that means everything that's here is also in list, right? And that's why list has a size, is empty, contains, add, and remove method, right? They're all specified by the collection interface, right? List adds extra methods, right? Lists are things that are indexed, so now you've got a bunch of methods that operate using an index, right? Like get, right, and set. Right? And a version of remove that also takes in an index. Right? If the list is indexed, then if you're searching for an element, it might be useful if I can find the index of that element. Right? And so there are other methods as well. Right? So the list adds extra methods, mostly dealing with indexes, right? Because collections don't deal with indexes. It turns out set is exactly the same as collection. Right? It doesn't add any extra methods to collection. Right? So set is just a plain old collection. Right? Sorted set adds some methods because you can do stuff with a sorted set that you can't do with a set. Right? Set does add the extra condition, though, that when you put something into a collection, the collection makes sure that the elements in the collection are unique. Right? So no duplicate elements are allowed in the set. That's not true about collection. Right? Collection will let you put anything you want into the collection. And map, again, it doesn't extend collection. Instead, it's its own separate interface. Right? So what can you do with a map? Well, it turns out you can't do a whole lot with a map. Right? You can put something in, you can get something out, you can remove something, and you can search. right? And then you can ask some basic stuff about its size. Oh, of course, you can ask for its keys and its values as well. Is there an iterator? Right. Notice there's no iterator in map, right? So if you look in the map interface, there's no method called iterator. So that means you cannot iterate over the map itself, right? You have to ask for its key set, and then you can iterate over its keys. Or you can ask for its values, and then you can iterate over its values, right? If you want to iterate over the rows of the map, right? The rows of a map are also a set, right? Because they consist of a key and a value, right? And the keys are unique. So the entries must also be unique, right? You can ask for its entry set and now iterate over the rows of the map. All right, so that's all I've got to say about collections for the time being, right? So we've introduced the idea of an interface. Later in the course, so I guess 3 weeks, 2 weeks from now, we're actually going to make our own interfaces and implement some classes that provide the functionalities that the interfaces define. Right. Any questions? All right. I will see you next week or tomorrow in the lab, if you have a lab tomorrow.